This is the inverse trig functions continued. And let's take a look at our first problem here. We got sine of inverse cosine of square root of 3 over 2. This is finding the trig function of an inverse trig function. So we got a trig function on the outside, we got an inverse trig function on the inside. Well, step 1. Set the inner inverse equal to p. So we'll set p is equal to the inverse cosine of square root of 3 over 2. Then we want to eliminate the inverse trig function. And how we do that is we take cosine of both sides. So we got cosine p is equal to cosine of inverse cosine of square root of 3 over 2. And that gives us cosine p is equal to the square root of 3 over 2. Now, we're going to use the x, y, and r formulas to find all these variables. Now this one's actually on a unit circle, so it's a little bit easier, but I like one set of steps that works all the time. So cosine p is equal to the square root of 3 over 2, and cosine is equal to x over r. Now this particular problem here, our inverse cosine is valid in these two quadrants, and specifically right here we said cosine is equal to a positive number. Well, cosine is a positive number is in this quadrant and this quadrant. So we're dealing with quadrant 1. Okay, so in quadrant 1, x is equal to square root of 3, and r is equal to 2. Well, we need to find y, so we got x squared plus y squared is equal to r squared. X is the square root of 3. Y squared we don't know. R is 2, so we got 2 squared. So that gives us 3 plus y squared is equal to 4. Take the 3 over, and we get y squared is equal to 1. Drop the squared, put a plus or minus square root around the other side. And we get plus or minus 1. And in that quadrant, y is positive in quadrant 1. Okay, so now we got our x, y, and r. We'll find the outer trig function. So if I scroll up, my outer trig function is the sine. So this is our outer, and this is our inner. So we're going to work with sine. So we come down here. Sine is equal to y over r. Well, y we just said was 1, and r, I don't know what we said. R is 2. So our answer is 1/2. Now we're going to use these same 4 steps to do all of these. Now again, when it's on a unit circle, it's a little bit easier, but I'm going to go with the steps work all the time. So let me save this. Trig inverse Trig functions continued. Page 01, PDF. And time for that to blow up, so let me start a new tablet. Okay. Let's look at our second example. We got cosecant of the inverse tangent of negative square root of 3. Now step 1, we set the inner equal to a variable like p. Then step 2, we eliminate the inverse trig function, so we'll take tangent of both sides. So we get tangent p is equal to negative square root of 3. Now I'm gonna write that in fraction form. So negative square root of 3 over 1. And let's think about quadrants. Inverse tangent is valid here and here. Right at this point, we said that tangent is equal to a negative number. Well, tangent's negative here and here. So the quadrant we're going to be dealing with is quadrant 4. Okay. Now tangent is equal to negative square root of 3 over 1. And tangent is equal to y over x. Well, if we look in quadrant 4 down here, y is negative. So y is equal to negative square root of 3, and x is equal to 1. Now, that's negative could be on the bottom. So you could have it on top or on the bottom. You may have to move it depending upon which quadrant you're in. Well, we need to find r. So we got r squared is equal to x squared plus y squared. X is 1, so we got 1 squared plus y, which is negative square root of 3 squared. 1 squared is 1. When you square a negative, it becomes positive, and then the square of square root of 3 just gives you 3. So we get r squared is equal to 4. Drop r squared, and normally we put a plus or minus square root on the other side, but we know r is going to be positive, so we can drop the negative, and square root of 4 is 2. Now step 4. Look at our outer trig function, which is cosecant. Cosecant is equal to r over y. So r was 2, and y is negative square root of 3. Now we'll multiply top and bottom by a square root of 3, and we get negative 2 square root of 3 over 3. And that's our answer. Let's take a look at this one. We got secant. I think I like the way I'm explaining this better than I did in class. It's one step that works on all of these. We got a trig function here and an inverse trig function here. Well, our first step, set p equal to the inner part, which is their inverse tangent of negative 5. Step 2, eliminate the inverse trig function. So we'll take tangent of both sides. Like that. And we get tangent p is equal to negative 5. Well, let's think about quadrants. Inverse tangent is valid here and here. Now specifically down right this step, we said tangent is equal to a negative number. Well, tangent's negative here and here. So we're again dealing with quadrant 4. Okay. So we got tangent is equal to negative 5 over 1. And tangent is equal to y over x. Now y is negative down in quadrant 4, so that's fine to have the negative up on top. So y is equal to negative 5, and x is equal to 1. And we've got to find r. That's our missing variable. Remember, you need x, y, and r to finish the problem. Well, r squared is equal to x squared plus y squared. X we said was 1, so we've got 1 squared plus y, which is negative 5 squared. 1 squared is 1, negative 5 squared is 25, so we get r squared is equal to 26. Drop a squared. Normally I'd put a plus or minus on the other side, but r has to be positive, so this just be square root of 26. Okay. Step 4. Now handle our outer trig function, which is secant. Secant is x over r. Now x we said was 1, and r is square root of 26. So multiply top and bottom by square root of 26. Don't want to leave a radical downstairs, and that would be our answer. Yeah, let's look at another one. My numbering was screwed up here. I rearranged the problems. I didn't like the order I had them in the class, but I didn't get them changed. I'm trying to get it done before 9. Got my show coming on then. Okay, first step. We'll set what's inside to equal to a variable like p. We got that. Then we'll, step 2, eliminate the trig function, the inverse trig function, so we'll take sine of both sides. Like that. So then we get sine p is equal to square root of 3 over 7. Now let's talk about the quadrant. Inverse sine is valid here and here. Now specifically down here we said sine is positive, which has to be either here or here. So quadrant 1 is the quadrant we're dealing with. Okay. Then step 3, we're going to use our x, y, and r formulas. Now sine is equal to square root of 3 over 7, and sine is equal to y over r. So y is equal to square root of 3, and r is 7. And we'll use our formula x squared plus y squared is equal to r squared to find our missing variable, which is x. Y is square root of 3, and r is 7. So square that, and that gives me 3. 7 squared gives us 49. Take the 3 over to the right side, becomes a negative 3, which gives us 46. Drop our squared and put a plus or minus square root around the other side. But in quadrant 1, x is positive, so this is going to be a positive square root of 46. Well, now we're going to look at our outer trig function. Cosine is x over r. X we said was square root of 46, and r is 7. So that'd be your answer. And let me save that. Okay, there it is. And let's look at our next problem. This is not problem 3, but we'll go with that. Okay. Now this one is different. We got the inverse trig function of a trig function. So we got the inverse trig function on the outside, and we got a trig function on the inside. Well, we're going to find the value of the inner. Excuse me. This is my inner, and this is my outer. Well, if I look at the inside, I got cotangent of negative 3 pi over 4. Negative 3 pi over 4 would look like that right there. This point here is negative square root of 2 over 2 and negative square root of 2 over 2. Now cotangent is x over y. So if I put the x over the y, these are the same. So cotangent is 1. Well, I just found the inner value. So then I have the inverse sine of 1. Now I'm going to set this equal to p. So I got p is equal to inverse sine of 1. I'm going to eliminate the inverse trig function. So I take sine of both sides. So I got sine p is equal to sine of inverse sine of 1. So we get sine p is equal to 1. Now for this particular one, I look it up on my unit circle, and sine is equal to 1 at pi over 2, which is valid for my inverse sine, which is negative pi over 2 to pi over 2. So that'd be my answer. Let's say now find a value. Okay. Let's look at our next problem. We've got inverse cotangent of negative square root of 3. Now we don't know what this value is. We're trying to find and we saw these in the last section. So we set it equal to a variable, set equal to p. Now we're going to take cotangent of both sides to get rid of that inverse trig function. And we get cotangent p is equal to negative square root of 3. Well, let's think of quadrants where we're looking. Inverse cotangent, this is the weird one. It's valid here and here. And let me double check that, just because I don't want to. That's the one that's kind of odd. Yeah. Inverse cotangent is, you can look in your books, valid between 0 and pi. And specifically here we said cotangent's negative. Well, cotangent's negative here and here. So we're talking about quadrant 2. Okay, so I'm looking at quadrant 2, and I'm looking for a cotangent is equal to this value. Well, this is x over y. So if I look at my unit circle, wherever that's at. Okay, so I put x over y here. I'd have negative 1 over square root of 3, which is negative square root of 3 over 3. That doesn't fit. Come down to here. X over y would be negative square root of 3 over 1, which is negative square root of 3. That fits. So we got 5 pi over 6. Now that's actually valid for where inverse cotangent is valid, because inverse cotangent is from 0 to pi. So that would be your answer. Okay, let's look at our next problem. We got cosecant of inverse cosecant of negative square root of 2. Now again, we set that equal to a variable, like that, and take cosecant of both sides. So cosecant p is equal to cosecant of inverse cosecant of negative square root of 2. So we get cosecant p is equal to negative square root of 2. If you would prefer, you could rewrite the cosecant as 1 over sine, and you could rewrite this as negative square root of 2 over 1. Create a fraction on both sides. If you got a single fraction on both sides, you can flip both of them. So this becomes sine p over 1 equals negative 1 over square root of 2. Which gives us sine p is equal to multiply top and bottom by square root of 2. So we got negative square root of 2 over 2. Okay. Now if I look where inverse cosecant is valid, that's valid here and here. Now here we're saying sine is negative. Sine is negative here and here. So we're talking about quadrant 4. So if I look here, negative square root of 2 over 2 for a unit circle. Y is sine is our y, which is right here. We got 7 pi over 4. Now there's a problem with that. That isn't valid for cosecant. Cosecant is from negative pi over 2 to pi over 2. Let me verify that. Yeah, it is. Okay. So what we have to do is we have to subtract 2 pi. And then that would give us negative pi over 4, which is valid in that range. Let me save that. And okay, why do you keep doing that? Keeps throwing me out of the application for some bizarre reason. This next one's a calculator-based one. We got cosecant of, or inverse cosecant of 7. Well, we don't know what this one is, so we'll set equal to a p, a variable. Then we'll take cosecant of both sides. So we got cosecant p is equal to cosecant of inverse cosecant of 7. So we got cosecant p is equal to 7. Those cancel each other out. Now, we didn't have inverse cosecant on our calculator, so we're trying to get to the point where we can put it in our calculator. But I can rewrite cosecant as 1 over sine, and this one I can rewrite as 7 over 1. Remember a little trick that I showed you? You can flip both fractions. So this is sine p over 1 is equal to 1/7. So we got sine p is equal to 1/7, and then I can take inverse sine of both sides. And those will cancel, and we got p is equal to the inverse sine of 1/7. Well, this one we can plug into our calculator. So if I come here, inverse sine, I'll do secant sine of 1/7. And to 2 decimal places would be 0.14. So 0.14. And that's our answer. Now you probably see a little bit of a trick here. You go from cosecant, inverse cosecant, to, oops, let's try it again. Inverse cosecant to inverse sine. When I do that, see how this 7 becomes 1 over 7? That'll always work that way. So it's a shortcut. You don't have to sit there and do all those steps I just showed you. Okay. Here we got inverse secant of negative 5 over 4. So I'm going to rewrite that as inverse cosine, and I'll flip the fraction. So it becomes 4 over negative 5. And that we can plug into our calculator. So I come here and do a secant cosine, negative 4 over 5. Doesn't matter where you put negative. Enter. And that gives us 2.5. Now this last one's kind of a little bit of a trick, calculator-wise. And you oftentimes see this with inverse cotangent. So we got inverse cotangent of, oops, negative 5 over 2. Okay, it doesn't change. It's still the corresponding trig function, inverse trig function. And this becomes negative 2 over 5. Well, let's type this into our calculator. So, let's see, secant tangent, and I said negative 2 over 5. Okay, we get negative 3.8. Oops, negative 0.38. Well, my eyes are bad. That looks right. The problem with that is inverse cotangent is only valid here and here. It's not valid down here at negative 0.38 down here. But we know with to get it up here, what we can do is we can add pi. So if I come over here and I go ahead and do a plus, and I do secant pi and enter, then we get 2.76, which is our answer. So, and you'll oftentimes have that with the inverse cotangent. You have to add a pi to it to get it up where it should be. Now remember, when we're talking about the values down here, and if I were to go through all those other steps and, take set this equal to p, take cotangent of both sides and so forth, cotangent's values here are the same as they are up here by our symmetry. So that's why we can do that. Yeah, let's take a look at one of these problems. We've got tangent, and then we got inverse cosine of u plus 2. Now these are like the first ones we looked at, so we're going to follow those steps. Now, first step is to set the inner equal to a variable, like p, like that. Second step was to eliminate the inverse trig function, so we'll take cosine both sides. And when we do that, we get cosine p is equal to u plus 2. Well, in step 3, we have to use our x, y, and r formulas. Now, cosine p I can rewrite as u plus 2 over 1. And cosine is x over r. So x is equal to u plus 2, and r is equal to 1. Well, we need to solve for y. So we got our x squared plus y squared is equal to r squared. Excuse me, x is u plus 2 plus y squared, and r is 1, so we got 1 squared. 1 squared is 1, and then I'll take the u plus 2 squared over to the right side, like that. We'll drop off our squared and put a plus or minus square root around the other side. Now normally I would worry about the plus or minus, like what should I do with it, since we got variables, not actual numbers or anything. But when we're talking about inverse cosine is valid in this quadrant and this quadrant. Well, y is positive in both of those. So y is going to equal to a positive square root of 1 minus u plus 2 squared. Okay. Now remember step 4 was then to find the outer trig function, which is tangent. Tangent is y over x. And y we said was a square root of 1 minus u plus 2 squared. And x was, what was x? X was u plus 2. So that would be our answer. Yeah, let's look at one more. So we got cotangent of the inverse secant of u minus 3. Still those same 4 steps we looked at. Now our first step is to set the inner equal to a variable like p. Like that. Step 2 is to eliminate our inverse trig function, so we'll take secant of both sides. And so we get then secant p, and those cancel and leave us u minus 3. Now step 3, use our x, y, and r formulas to find x, y, and r. Well, secant p is equal to u minus 3 over 1, and secant is equal to r over x. So r is going to equal to u minus 3, and x is going to equal to 1. So then we got x squared plus y squared is equal to r squared. We want to find out what y is. Well, x is 1, so we got 1 squared plus y squared equals u minus 3 squared. So I got 1 plus y squared is equal to u minus 3 squared. Take the 1 over, and we got u minus 3 squared minus 1. Drop off our squared, put a plus or minus square root around the other side. We get that. Now we're again dealing with something that's only valid in the first two quadrants, inverse secant, which is valid from 0 to pi. So y is going to be positive there. So we got square root of u minus 3 squared minus 1. And step 4, we look at our inner or outer trig function now, which is cotangent. So come down here. Cotangent is x over y, and x was 1, and y is the square root of u minus 3 squared minus 1. That's a pretty good bet they don't get rid of the square root downstairs, so we'll leave our answer in that form. And let me save that. Actually, I want to write something else down here first. Just to summarize, our inverse sine is from negative pi over 2 to pi over 2. Our inverse cosine is from 0 to pi. Our inverse tangent is negative pi over 2 to pi over 2. Our inverse cosecant is from negative pi over 2 to pi over 2. Our inverse secant is from 0 to pi. And our inverse cotangent is from 0 to pi. Again, inverse cotangent is the bizarre one. I never did write those down before I started working the problems in this section. But those are important to keep in mind when you're working these to make sure everything falls where it should, quadrant-wise and everything. So let me save that. And I finished with 6 minutes to spare. I didn't think I was going to get done by the time my show started. Of course, this silly thing. I don't know why it keeps throwing me out of it. But okay, let me stop the recorders. There we go, and we'll stop the other recorder too.